Good morning, my dear students. Today we are discussing about three-dimensional transformations. So, before going on to the three-dimensional transformations, you are very familiar about the two-dimensional transformations. So, in the two-dimensional transformations, we are taking about the x and y axis. Now, in the three-dimensional transformations, we will take about the x, y, and z axis. That means, in the 2D transformations, you are familiar that we have x and y. So, in the 3D, we'll take about the x, y, and z. So x, comma y, and z. So in order to represent in the three-dimensional the transformations, so we have the three types of techniques here. It's all about the translation, rotation, scaling. So the translation will take about the how a particular point is moving from one place to the other place. That means we are shifting a particular point or a particular image to one point to the other point. So, okay. So in this we take first I will see. So in the 3D transformations we will take about the x, y, z, and so in order to represent the three-dimensional transformation we will take about the homogeneous coordinates also. That means here, for example, if I am taking about the translation technique. So here, what I am doing here simply, I am moving an object from one place to the other. That means I am translating the object from a particular distance here. So I am moving. That means here. So for example, if I am taking about the object, so next slide will take about the object here. Please see. So here I am taking about a particular object. So that means I am moving the object from one place to the other. For example, if I am considering about a point, for example, if I am considering about a point, so initially we have a particular point like this, so P, and I am taking about a particular point P like here. So here I am moving the point from one place to other place. That's what I want a new point called P dash. So here we have the x, y, and z coordinates. Okay. So here, for example, if I am taking, that means here I am translating. That means I am translating a point from one place to the other place. So here the object can be moved from one place to the other place also. So in this, if I am considering about the with the homogeneous coordinates only, I want to consider. That means I am drawing about the x dash, y dash, z dash, one equal to. So I am taking about the translation as 1 0 0 tx, 0 1 0 ty, 0 0 1 tz, and 0 0 1, and that's called I am adding the homogeneous coordinate here, and I am multiplying with the what are the old coordinate I have, that's called about the P point, x, y, z. So by multiplying these, I am getting the new coordinates called about the P dash equal to, so I am getting about the, so here I am getting the new coordinates called about the P dash. So by giving a particular translation vector here, so by giving a particular translation vector, I am going to get the new point here. Okay, so this is all about the translation here. For example, if I am going for the scaling, so what exactly I will do in the scaling here? So in the translation, what I am doing here simply, I am moving the point from one area to the other area. So in the scaling, what I am doing here simply by the homogeneous coordinates. So I am writing the 4x4 matrix, and I am moving. That means here I am reducing the size of the image. Either I can increase the size of the image or I can decrease the size of the image here. So for example, see, if I am taking the particular three-dimensional here, so if I am taking the particular image like this. So for example, if I am taking the image like this, so here I will draw the image. So if I am considering like this, so if I am applying the scaling concept, for example, if I am applying the scaling concept, so what I am doing here, simply I will increase the size of an object. So here I am increasing the size of an object like this. So in the scaling, what exactly I am doing here, simply what are the object we have, simply I am trying to increase or I am trying to decrease the size of the object here. So that's what about the scaling in the three-dimensional. So if I am going for the rotation here, so if I am going for the rotation, so what exactly I am doing here? So here I am trying to rotate the object here. So what are the things that are done in the two-dimensional? For example, in the two-dimensional also we are rotating, no? So in the three-dimensional we are trying to rotate the object in the three-dimensional view. So for example, so further I am taking about the object theta equal to cos minus sin theta. Here I am taking about the anti-clockwise direction here. So minus sin theta 0 0, sin theta cos theta 0 0, 0 1 1 0 0 0 1. So here I am adding the particular homogeneous coordinate. So in the two-dimensional, so there I am taking only the 2 by 2 matrix with one homogeneous coordinate is called about the 3 by 3 matrix. But here I am taking about the 3 by 3 matrix with adding a homogeneous coordinate. I am taking about the 4 by 4 matrix here. So now see. Okay, now I am taking about the rotation. So if I am considering about the types of rotations here. So if I want to rotate with respect to the x-axis, I can rotate counterclockwise. Okay, if I can rotate a particular object. For example, if I want to rotate a particular object with the y-axis, I can rotate the object. If I want to rotate an object with the z-axis, I can rotate a particular object z-axis. So rotation around the coordinate axis. So around x-axis, around y-axis, around z-axis. So in all these cases, what I am doing here exactly, with respect to a particular coordinate, I am trying to rotate an object. I am trying to rotate an object. So for example, if I consider that, so on the x-axis, I am rotating with respect to the x-axis there. If I observe the diagram, so see around x-axis or x theta. So with respect to the x-axis only, I am trying to rotate the object. For example, if I consider about if I want to rotate about the object with respect to the y-axis, so I am rotating around the y-axis there. If I want to rotate about the z-axis, then I am to rotate about the particular object with respect to the z-axis. So in what way? What I am doing here simply I am trying to rotate the object in any sort of the axis here. So now before going on to how to rotate an object with respect to the axis. So basically we are having two types of methods. That means we have two types of methods to rotate an object here. So first one we consider about an object that is parallel to any one of the coordinate axes. Any one of the coordinate axes. This is what about the first method. So if I next method, object that is not parallel to any one of the coordinate axes. So if I consider these methods, my dear students, if I consider these methods, so in the two dimension also we have used the methods to rotate the objects here. Same way we are considering same concepts. So by adding the z-axis here, so I am trying to rotate the object with respect to a particular axis here. So for that I am considering the first method. That's what about the rotation around an axis that is parallel to x-axis. So here I am considering an object which is parallel to the x-axis here. That means the object is parallel to the x-axis. For example, the same concept, I can take the object which is parallel to the y-axis. I can take the same object which is parallel to the z-axis also. So, but for the example consideration, I am taking the object which is parallel to the x-axis here. So now, if I consider the first diagram here, so the vertical position of an object that is, that's called the initial position of an object that is there in the particular diagram. For example, if I consider that, so there we consider that the rotation axis is parallel to the x-axis there. That means now, how to rotate this object? So how to rotate this object? For example, the axis is parallel to the x-axis. So what the method I want to rotate that? For example, if the object is parallel to the y-axis, what the method I want to do here? So if the object is parallel to the z-axis, what the method I want to do? So what are the method we follow? That means here, whenever if the particular object is parallel to x-axis or the y-axis, z-axis, so we will follow a particular method in order to rotate an object. So now the first diagram, what we have considered here? So the object is parallel to the x-axis. Now if you consider the diagram here, so I am taking a particular triangle here, okay, a prism, so a rotation axis. Now what I have to do here? So first of all, so now we know that the object is parallel to the x-axis here. So now I am trying to move the object which is coincide with the x-axis. So the second diagram, if you observe that I am shifting the particular object that is must be coincide with the x-axis. Now it is coinciding with the x-axis. Now we have the method that whenever if a particular object is coinciding with the x-axis, I can easily rotate the object here. So in the third diagram, what I am doing here? So rotating object through an angle theta. So what are the angle I am mentioning here? I am rotating the object here. So before that, please see. So here what I am doing here? Translating. That means here. So whenever if I am moving the object from a rotation axis to the a particular z axis, what the method I am following here? I am following a translation technique. So a translation. That's called about translation. So I am doing the translation. So after reaching, that means after doing the translation, what I am doing here? I am rotating an object through a particular angle. So after rotating, what I am doing here once again, I am retranslating the object. That means I am once again moving the object from the new position to the old position. So if I observe the diagram same. So rotation axis. So what I am doing here? So from the rotation axis it coincides. That means it's parallel to the x-axis. Now it is translated. Now after what I am doing here, I am rotating the object. Now what I am doing here, I am retranslating the object from the old position to the new position here. So that means here what I am doing here, a translation, a rotation, and inverse translation. That means here I am doing the concept called the translation, rotation, and inverse translation. So this is the concept that is related to the object which is parallel to the x-axis. That's all about the x-axis. So we can, if a particular object is parallel to the y-axis also, I can consider that. If a particular object is parallel to the z-axis also, I can consider that. Now, so this object is parallel to the particular coordinate axis here. Now, if I do a particular object which is not parallel to the particular coordinate axis, what I want to do here? So here we have the method. That's called about the second one, rotation around an arbitrary axis. Now we see. So what I'm considering here? So if a particular object is not parallel to the particular coordinate axis, Now I am taking the initial position of an object here. So I am taking the initial position. That's called about the P1, P2. That's called about the I am taking a line here. So now whenever if I am considering a particular object which is not parallel, first of all I want to make the object parallel to the particular coordinate axis, then only I want to make these translations or the rotations or whatever it may be, the operations I have to do here. So first what I am doing here, so here I am doing, so the first step, initial step, what I am doing here, so translate, that's called, so I am taking the particular object, I am coinciding the object with the particular coordinate origin. I am translating a particular object with the particular coordinate origin here. Step 1, translate P1 to the origin here. So whenever if it is coincide with the particular origin, now I can move either in the x or either in the y or in the z direction. Now what I am doing here? So step 2, what I am doing here? Rotation. So here I am rotating a particular object with respect to the x-axis or with respect to the z-axis or y-axis. So now I am rotating with respect to the z-axis here. So now the object is parallel to the particular z-axis here. So the object is parallel to the particular z-axis here. Now whenever if the particular object is parallel to the z-axis, now what I am doing here? I am trying to rotate the object. Now in the third diagram, what I am doing here? I am trying to rotate the object for a particular angle in the anti-clockwise direction. So after rotation, what I am doing here? I need to move the object to the original position where I am taking the object from the coordinate origin. No? So I am once again moving the object to the coordinate origin. So okay, so in the first diagram, translate the object. So that means here, so I am shifted the object and So I am coincident with the particular origin, and I am moving the particular object to the particular z axis, and there I have rotated the object. The next diagram what I am doing here, simply after rotation, I am simply moving the object to the original orientation. That's called about the coordinate origin. So now, after the moving the object to the coordinate origin, so what the step I am doing here, simply I am retranslating the object. That's called I am translating the rotation axis to its original position. So object to its original position. So now, if a particular object is not parallel, so I want to use this method. So first what I am doing here, translation, so rotation, so okay, rotation with the z axis, and rotate the object around the z axis. Now rotate the axis to its original orientation and translate the object to its original position. So this is called about the rotation. So by using the object which is parallel and which is not parallel, we have to use these two methods. Now we are going for the particular scaling here. So I think you are familiar with the scaling, no? So what changes we have done in the scaling here? Change the coordinate of the object by scaling the factors. So if I observe that p dash equal to s dot p. So I am taking about a particular point here. So I am trying to increase the size of an object, or I am trying to reduce the size of an object here. So by using the particular scaling method, I am trying to increase or reduce the particular object. So if I consider the matrix, 4 by 4 matrix here, x dash, y dash, z dash, 1 equal to sx. So called sx and sy and sz are called the scaling factors here. Sx, xy and sz are called the scaling factors here. So sx 0 0 0, 0 sy 0 0, 0 0 sz 0, 0 0 1. I am taking about the unity matrix and I am trying to multiply with the x, y, z, that's what about the original points, and I am getting the particular scaling factor here. So this is the method that is needed to scale a particular object. So now we'll try to how we want to scale a particular object with respect to the particular coordinates. So we'll take that. So I am considering a particular object. So that's called about the original position of an object. It's called about the original position of an object. It's called about the original position of an object. Now here I am taking about the x of y of z. That's called about the point which I want to scale. That means the image which I want to scale here. So I am trying to scale that object, and I want to make the object either be small or the large, whatever it may be. So I am trying to do that. So first, in order to do that, what I have to do here? So directly I cannot scale the object. So here I want to follow a particular method which will help you to make the changes for a particular object. What I am doing for that? First of all, I am taking an object. So next, what I am doing here? I am applying the method called translation. So what I am doing here? First, I am taking an object and I am trying to move the object. That means I am trying to translate the object. So for example, you know that whenever if a particular object is like this, if I want to move to the other position, for example, from this position to this position, I need to apply only the translation technique. Same technique I am applying in these concept also. So I am moving the object from a particular position to the particular position. So the red dot we can consider that as the original position of a particular object. So I am moving the object to the new position. That's what I am doing about the translation thing. So now whenever if a particular object is moving, where I want to move that object? First of all, whenever if I am moving, I want to move the object to the particular coordinate origin. So that's why I am moving to the coordinate origin here. So I am moving the particular object to the coordinate origin. So with respect to the coordinate origin only, I need to scale the object. I need to scale the object. So I am trying to scale the object now. So now it is scaling the particular object. So what type of scaling factor here? For example, if I am applying the scaling factor, so I count the scaling factor only, I want to scale the object. So I am scaling that. So after scaling, whenever what are the scaling? Account the scaling factor. I have done the particular scaling of a particular image. Now after scaling, what I am doing? I want to retranslate the image, the object from a particular position to the original position. That's called an inverse translation. So I am moving the object from a particular position to a particular position. So I am once again moving the object to the original position. So if I observe that the original position, and I am doing for the translation where I am scaling and inverse translation. So now if I consider that scaling with respect to the fixed point. So here I'm taking out a fixed point now. So with respect to the fixed point only. First about the translation. So Tx, y of zf and s is the scaling factor. Next retranslation. So if I observe the matrix, for matrix. So about the first matrix I'm about to call the translation. So about scaling and retranslation. So if I multiply all these matrix, we get a particular matrix which is that means which is scaled from a particular object here. The object. So by using all these, what I am doing here, by using all these, so I am trying to translate an object, or I am trying to rotate an object, or I am trying to scale an object. So these are the methods that are needed to transform an object in the three dimension. So this is the method that is applied for the scaling with respect to a fixed point. So here also what I am doing here simply, so I am taking a particular object and translating and scaling it inverse translation. So whenever if I consider the scaling, whenever if I am considering the rotation, or whenever if I consider about the particular about the translation also, here we are using the methods that are needed to change the position of an object, or the change the size of an object, or the orientation of the object. That's called about the angle of, that means here I am considering about, that means here I am rotating about the object here. So in all these cases we are trying to move the object from one place to the other place, or we are trying to reduce the size of an object, or we are trying to rotate the object in the clockwise or in the anti-clockwise. So if I observe all these things, so what you are getting here simply, so by using these three-dimensional techniques, we are trying to move the object, or we are trying to rotate the object, or we are trying to reduce the size of an object. So the same concept, for example, see, in this scaling also we are taking about translation, scaling and inverse translation. No? So in this also, we are only, that means here, we are rotating the object. That means in the x-axis or in the y-axis, or in the z-axis. So we are taking these methods. Okay. Okay, thank you. Thank you, my dear students.